it's George, and I'm back again. And I'm here to discuss some stuff. I'm going to try to educate some people because they don't know this, because they don't have what I have to be able to look at. Okay, with that being said, we're going to go to this scene, the scene from the movie. Okay?
Down 911! My screen's full. They're all over the place. Bogies are breaching the atmosphere from Finland down the North American seaboard.
Okay. Now, that part is correct when you have a type of meteor shower like the 1833. I will show you what is incorrect. Okay. Now, after watching that little clip of Armageddon, okay, that is what's incorrect about those particular types of meteor showers. Those meteors do not go that fast. And I'll explain why. Okay. Now, during the 1833 meteor shower, there was a lot of meteors. Okay, we're going to go to the little graph over here. We're going to go to the little graph over here, and I'm going to explain. I'm going to explain how these rocks got through and how I know this. Okay, there's a thing called Joul's heating. It's producing heat with electrical currents. Okay, we'll go here. The meteor trail has plasma in it, okay? It can trigger sprites. Okay? Now, there were 500, or there were 50 to 100 to up to 250,000 per hour, and some were the size of Jupiter. Okay, now, if your meteor is the size of Jupiter, okay, there's going to be more burning. There's going to be more of a plasma trail. Okay? All right. The mesosphere fills with noctilucent clouds, which are ice crystals, and the sprites, which are electrical discharge. They're akin to lightning. It's sort of like flying through lightning. Okay, now, if you have 250,000 of them at one point passing through the mesosphere here, all different sizes, what is that doing to the mesosphere? What are all those ice crystal clouds and all that plasma and sprites doing to the mesosphere? This is what people don't understand. They don't take it into account. They don't take that stuff into account. Okay. Well, here we have. Okay, I'm gonna read this. Okay. Electrical heating causes the temperature to rise. It melts the rock incongruently and generates a thin fulgurite layer on the surface when the temperature is above the granite melting point. With that being said, now, in incongruent reactions, the initial mineral is leached and modified and converted into a secondary mineral. which means it alters the rock. Okay, coatings or crusts of glass formed on the rocks from a lightning strike are called fulgurites. Now, can electricity heat a rock? The current is able to pass through the rock and induce significant heating. Now, what that is when you have that much, what do you want to call it, the sprites and the plasma trail and the ice crystals. When you mix all that stuff together, you're going to get a reaction. Okay, so in 1833, meteors were traveling through there like this, and the mesosphere was electrified. It was totally lit up with sprites. People said they seen auroras, and other people said it was impossible. I believe that they saw what they saw. And what they saw, it was triggered by what went on in the mesosphere. Now, a lot of people don't take into account the size of the meteors that were coming through. And the speeds weren't horrific, and I'll get to that here in a minute. Okay, now, rocks coming through like this, yeah, it looks, this is a piece of metal, okay? But these are like fulgurites. This is what fulgurites is. And a whole rock isn't that way. Just a little bit of it. This one has a lot more of the stuff on it. And if you look up fulgurites, and read the stuff that I'm telling you, you'll understand. Same thing here. Which at some point, these rocks traveled through electricity. Now, because of the process that went on, is the reason why you got rocks like this, and this is a solid piece of iron. Okay, it's metal. This is metal. Whether people want to believe it or not. This is another burned piece of fragment that came in. I couldn't get this stuff cleaned off. But the crystals and everything in it. But this coating doesn't come off. Now, if they were flying through lightning, little sprites, and we were talking about there would be literally millions of up there surrounding the rocks that were coming through. That is penetrating toward the center of the meteorite, and that is going to heat the meteorite, or it's going to heat the meteor from the inside outward. If you know what Joel's heating is, you can look it up. And you know, but some people aren't going to get this. Some people might get it, but by the things that I find, I can look at things. Okay, now, on a small scale, a very small scale, we're going to do the 1833 meteor shower. Ta-da! Okay, this coin right here represents a Jupiter-sized meteor. This one is a medium-sized meteor, and this one is a small one. And they got the pennies too, they're small ones. Okay, when you look at this, and this is a very small scale. This isn't 100,000. This isn't 250,000. This is what the 1833 meteor shower would have looked like, but it would have been a little bit more sophisticated. And the blue line would have been all the ones incoming from space. You wouldn't have been able to see them until they entered the atmosphere. And they would have been coming in, and they would have entered the atmosphere. Okay, this isn't even 100,000. But if this was an actual meteor shower, that would be a lot of meteorite smoke. Meteorite smoke. the trail that's left that creates the plasma, and then you get the noctilucent clouds, and then you get a combination of everything. But nobody wants to research this stuff. You don't take into account what the rocket fuel is doing. The rocket fuel is just like meteor smoke. It does the same thing. And that's why you're seeing all these meteorites and breaking through and everything. But this particular type of a meteor shower, because of the way the speed and the direction that everything was coming in, these things were not going very fast. If anything, they were dropping to the ground like this, like big balls of fire. They were on fire when they came out of the mesosphere, but it was just like a big ball of fire, just like this thing. And this would have been hot, it would have been on fire, and the fire would have went out. And then that's what you got left over from it sitting around for a long time. When they sit around for a long time, yeah, they're going to still have the black crust on them. But this thing is hideous and disformed. But what's really interesting is, like I said, all the shiny crystals and everything in this black area. This is one that I've never really seen. Now, people can believe this whether they want. They don't have to believe it. But what you see up there in Armageddon, that won't be the exact thing that happens. It'll be close to that. But the meteors won't be traveling the speed that they're showing in the movie. If it's a case like, if you look up Sodom and Gomorrah, and the 1833 meteor shower, and some of the other ones throughout history, the meteors weren't going very fast. And that's why people said they were like snowflakes, hailstones, like apples falling from a tree. That stuff doesn't go hundreds of millions of miles an hour, or thousands of miles an hour. You go out and shake an apple tree and you tell me how fast the apple goes to the ground. It doesn't go to the ground that fast. And this is the point that I'm trying to get across to people, but they don't want to listen, and that's fine. When one of this meteor shower happens, you'll get what I showed you on TV, except there won't be all the explosions and everything. But there will be a lot of damage, and a lot of people will get hurt. Anyways, I hope that clarifies more of what I'm finding. I'm trying to be as decent as I can about this, and like I said, I just did everything on a small scale. When you look at the picture, then imagine 250,000 of those in the sky all at once, and some of them the size of Jupiter. That's what scared people. They weren't coming down that fast. They were coming down slow. Anyways, I'm done.